Hey everyone, welcome to ML Innovate Hub. Today, we're diving into the fascinating world of neural networks. Ever wondered how machines learn? Stick around and by the end of this video, you'll be well on your way to building your very own neural network. Neural networks are everywhere around us, from voice assistants on our phones to recommendation systems on streaming platforms. Understanding them gives you the power to shape the future. Learning to build your own neural network is like unlocking a superpower. It's not just about programming, it's about creating intelligent systems that can solve real-world problems. Understanding neural networks. So what is a neural network? Think of it as a computerized brain inspired by the human brain. It's made up of layers of neurons working together to process information. There are three main parts. The input layer receives data, hidden layers process information, and the output layer produces the result. Weights and biases. These are like the strength and bias of connections between neurons. They make the network adapt and learn. Getting started. Setting up the environment. Let's get practical. First, make sure you have Python installed. Then install TensorFlow, a powerful library for building neural networks. Importing libraries. We'll use libraries like NumPy for numerical operations and Matplotlib for visualizations. Importing them is as simple as copy-pasting a few lines of code. Building your first neural network. Data pre-processing. Before we dive into code, let's prepare our data. It's like cleaning your room before starting homework. We'll discuss feature scaling, ensuring all data plays well together. Designing architecture. Now let's design our neural network. How many layers, neurons? We'll keep it simple for now and gradually explore more advanced concepts in future videos. Training and evaluation. Forward and backward propagation. Imagine teaching a computer by showing examples. That's forward propagation. Backward propagation corrects mistakes, making our network smarter over time. Loss functions and optimization. Loss functions measure mistakes, and optimization algorithms fine-tune our network to minimize those mistakes. It's like adjusting your aim to hit the bullseye. Tips and best practices. Common challenges. Building your first neural network can be tricky. We'll share common pitfalls and how to avoid them, like the importance of having enough data for training. Improving performance. Tips like adjusting learning rates, experimenting with architectures, and being patient can significantly boost your network's performance. We've covered a lot today, from understanding the basics to building and training your first neural network. Now it's your turn. Dive into the world of neural networks and don't forget to like, share, and subscribe for more exciting content. Happy coding. Additional context. Activation functions. Activation functions determine if a neuron should be activated. They add non-linearity to the network, helping it learn complex patterns. Common ones include ReLU, sigmoid, and TAN. Neural network types. Feed-forward networks are standard. Recurrent networks process sequences, e.g. time series, and convolutional networks excel at image-related tasks. Real-world applications. Neural networks power image recognition like in self-driving cars, natural language processing, chatbots, and even healthcare, diagnosis prediction. Overfitting. Overfitting happens when a model memorizes the training data but fails with new data. It can be prevented by using more data, regularization techniques, or dropout layers. Hyperparameter tuning. Finding the right values for parameters like learning rate or the number of hidden layers improves a network's performance. Interpreting results. Evaluate your model using metrics like accuracy, precision, and recall. Visualize results and understand if the model is making reasonable predictions. Feel free to ask any follow-up questions.